Hello and welcome back to another video, which means you're right, there is going to be another joke. Why did the banker quit his job? Because he lost interest. I thought that was a pretty good one. All right, so today we are talking about volumes of rotation or revolution. It's up to you what you want to call it: rotation, revolution, etc., etc. This used to be in advanced, but it has moved up into extension. So I don't think it's too bad, but let's go through it together and see what we can make of it. So basically, we're saying that solids, 3D shapes, they can be formed by rotating a bounded area around the x-axis or the y-axis. Now, let me show you what I mean, because it's hard to understand what that truly means. So what I'm saying here is if I'm, let's say, for example, created an area and I bounded it between these two. So I've got some sort of graph and I'm bounding it, right? So there's this area here and there's an area under a curve. I know how to do that. I do that by integration, but that's a 2D shape. Now, if I was to rotate it around the x-axis, so I want you to pretend that I'm just going to spin that x-axis this way and kind of like almost like a drill bit. What's going to happen is it's actually going to create a it's going to create a solid, right? It's going to create a solid that's going to be rotated around this way. It's kind of going to look a little bit like this, a little bit like this. And you can kind of see how we've kind of created this solid by rotating it around the x-axis, and it makes a 3D shape that has a volume. Okay, that's what we're going to learn how to find. Hopefully that diagram makes it clear enough to understand. If not, sorry, can't help teach a 3D concept in a 2D space. Okay, so now let's talk about the actual formulas. So the way that you'd find the revolution about the x-axis looks a little bit like this. You still have between B and A. But if it's around the x-axis, what you want to do is you have y squared dx. And the only difference is I put the pi out the front. Some textbooks will put the pi in front of the y squared, but I like to put it all the way out the front. Okay, the reason that we rotate it by pi is it makes sense because we're rotating it 180 degrees, and that will give us the full 360, right? If we just rotate it once, that's enough for us to get both sides. So that's where the pi comes from. And so here's the key thing here. Okay, if we're rotating or revolutionizing, if we're rotating about the x-axis, the rotations about the x-axis need to be, and I've left room for this, they need to be, and I'll leave it in blue so you can see, they need to be with respect to x. Okay, so if you're rotating about the x-axis, I need to see a dx. Yep. And I also need, and the basically A and B is your x values. Okay. So very simply put, very simple, very similar to the example we did before. What I need is I need some sort of graph, can be whatever. I'm rotating around the x-axis, so I'm rotating around this way. I've got two values, let's say A and B. Those are my x values, okay? And I'm rotating around this way, so it's going to end up kind of looking like this, right? Rotating around this way. Okay, it's going to create some sort of dish looking shape. Yep. So that's what the rotation around the x-axis will be. And this here is your formula. Okay, so if I was to rotate around the y-axis is a little bit different. If I was to rotate, and I should write out here volume equals. If I was to write for the volume here, volume, if you're rotating around the y-axis, is going to still be between B and A, but this time it's going to be x squared dy, right? So the note here is if you're rotating around the x-axis, you need to rotate around the dy. So if you're rotating around the y, you need dy. If you're rotating around the x, you need dx. And also, and A and B need to be the y values. Okay. So we need to be bounded by y values this time. So what I mean by that is, if I was to draw another one, right? So let's say, for example, I'm working with this. The difference now is I'm going to rotate around the y. So that means I'm going to rotate this way. So that means if I had, let's say, this time that's my A and my B. Now notice how this time my A's and my B's are my y axes, not my x axes. Okay. So that means it will end up rotating around this way. And it's almost going to create some sort of like bowl-like shape. Yeah, get the idea. And so it will rotate around this way. And so create some sort of big, nice bowl. And it will create that kind of shape there. That's how it works. So just remember, if it's, and don't forget, I don't, why am I like this? I literally came in prepared and I just don't know why. I just, but yeah, you need the pi and it needs to be x squared dy or y squared dx, depending on what you're rotating around. Okay. Okay, so let's try an example here. Find the volume of a solid when y equals x squared is rotated by the x-axis between x equals 1, x equals 3. Now do me a favor. I know some of you guys do not like sketching. Sketch everything, not even joking. All right, so y equals x squared. Nice parabola between x equals 1, x equals 3. Now keep in mind, what I said was a sketch. I don't want a graph. I just want a rough idea so I can see what I'm actually trying to do. So I can see here that if I was to rotate this, it'll kind of look a little bit like that. It'd be some sort of rotation around here. Yeah, that's the rotation because I'm rotating around the x and it's between 1 and 3. Okay, I'll go over 1 and 3 in a different color so you can see it. There's your 1, there's your 3. So that means to find the rotation, remember your volume is going to be given by pi between b and a, and for rotating around the x, it's going to be y squared dx. Yeah. So in other words, here my volume is going to be pi. And what are my two x values? Because I'm rotating around the x, it's going to be 1 and 3. And now y squared, I know y equals to x squared, so y squared would be x squared squared dx. Is that making sense? So y squared, because I know what y is x squared. But what I want to do is I want to square it. So it's y squared, which is x squared squared. Okay. So now we just integrate as usual. I'll leave the pi at the front to make my life easy. And then that's just going to be the integration of x to the 4 dx. And so that becomes pi. This becomes x to the 5 on 5 just by integration between 1 and 3. And that's going to be, I'm not going to calculate it because I don't think I can. So leave pi on the outside and it's going to be 3 to the 5 on 5 minus 1 to the 5 on 5. And so it's going to be basically 3 to the 5 take away 1 all over 5. So as clean as I can get it without using my calculator. You know what, I'll do it just for you guys. Okay, no one else would get this. 3 to the power of 5 is 243. So 243 take away 1 is 242 all on 5. It's cubed, right? Because we're talking about volume now. That there would be your answer. Okay, now we could, if there was a more specific question, we could, express it with decimals. But if they don't ask, generally you want to keep it as exact as possible. So the pi is going to be messy. So I'll just multiply the pi on and that's how I'll get my answer. Yep. Okay. Let's do one. Find the volume of the solid when y equals root x is rotated about the y-axis between x equals 1 and x equals to 4. Now, rotate it around the y-axis, but take a look here. X equals to 1, x equals to 4, and I've even got something in terms of y. Okay, so that's not what I want. But regardless, let's take a look here anyway. Let's do a quick sketch. Start with a sketch. So we have y equals the square root of x. So that's actually going to look like this. Okay, it's kind of like a sideways parabola, but only the top half. And I'm rotating it around the y-axis. So that means I'm rotating it this way. And I'm rotating between x equals 1 and x equals to 4. So let's say that's 1. Let's say that's 4. And I'm rotating around the y. So it is going to be somewhat this way here. Right, that's the rotation that I'm making. And that's the solid that I'm forming here. Kind of like this. Yep. Rotating a solid there. And I should go over, that's 1, that's 4. Oh, actually, you know what? I've already made a mistake because that's y equals 1 and y equals 4, isn't it? So that means in that case, let's rethink this. It's good that I'm making these mistakes so you can see how they are as I go, okay? So that means x equals to 1 and x equals to 4. Okay, so we want to find what those are. That's x, but technically we want to bound it with the y. So let's work at this systematically. First things first, my formula for rotating around the y-axis is going to be x squared dy between b and a and pi out the front. That there's your formula for the solid. Now, let's substitute what I do know. I do know I need x squared first of all. Okay, so if I took a look here, the square root of x, or y equals the square root of x. Now, what I need here is I need an x squared. Okay, so what I will need to do is let's find a expression that works a little bit more nicely for me. So if I square both sides here, I have x equals to y squared. Now, so far, so good. Okay, we're basically there. But now what we do is we want x squared. So when we substitute that in, we'll get v would equal to pi. I'm going to leave those a's and b's blank for now. But we're going to have x squared. So it's going to be y squared, y to the power of 4, or y squared dy. And it makes sense because we're integrating it with everything with respect to y. So that means everything should technically be y. Okay, now the other thing is the values, okay? So when x equals to 1, I have to find out what y equals. And when x equals to 4, I have to find out what y equals. Now substituting it into this formula here, I can see that it's just going to be the square root. So that means y equals the square root of 1. That's nice. Y is just 1 and 1. But when x equals to 4, y equals the square root of 4. And that's going to give me 2. So that means, remember, if I'm rotating around the y-axis, I need the y value. So it's not going to be 1 and 4. Because of our function, it's actually going to be 1 and 2. So that there now becomes my integration. Okay. Now, just in case you were a little bit unsure on where those came from, y equals the square root of 1, which is 1. And y would equal the square root of 4, which is 2. Do you like how I fixed that? That was a good one. Okay. Let's go through this. Integration, make sure we're all good. So volume now becomes pi outside of, again, this is 2, 1, y to the 4 dy. That looks like an integration that I want to do. And so this becomes y to the 5 on 5 between 1 and 2. And again, this just becomes pi outside of y to the 2 all over 5. Take away 1 to the 5, which is just 1 on 5. So I don't know why I wrote y to the 2. It should be 2 to the 5. Oh man, what is going on? Okay, so this should become 2 to the power of 5 on 5. Take away 1 on 5. And pi is going to be all that 2 to the power of 5. I hope it's 36. I don't know why I said 36. It should have been 32. So 32 take away 1 is going to be 31 on 5 units cubed, because we're talking about a volume. And that there is how you find the volumes of a solid rotated around an axis. Enjoy, and I'll see you guys later. Bye.